Hello everyone, in this video we're going to talk about the Pythagorean Theorem and its converse. So we'll start off with the Pythagorean Theorem. We have a right triangle listed or shown right here, and that is what the Pythagorean Theorem is all about. We have to have a right triangle, and once we have a right triangle, we know to note that it's a right triangle. We have that right angle box right there. And then we have three sides obviously to a triangle, but we have a vertical side and we have a horizontal side. Those two sides, A and B, those are called the legs. Okay, so A and B are called the legs of the right triangle, and C we refer to as the hypotenuse. Okay, so the hypotenuse is C and the other legs are A and B. It doesn't matter which leg is A or B, they're interchangeable. And that brings us to the Pythagorean Theorem, which is a squared plus b squared is equal to c squared. Now, once we're working with right triangles, there are some numbers that once we plug in, we get whole numbers for A, B, and C. And when that's the case, we call those Pythagorean triples. And we see some of the most common Pythagorean triples that exist, that we see when we're working with these problems. So 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. So just to give you an example of what we're talking about, this would be 3 squared plus 4 squared equals 5 squared. Okay, so the hypotenuse C always has to be the longest side. And so in that case, that's the largest of these three numbers. So here, this would give us 9 plus 16 equals 25, and 9 plus 16 is 25. So 25 equals 25, and that's what we're referring to when we talk about a Pythagorean triple. Okay, so let's look at some examples. So these first two, we're just going to find x by using the Pythagorean theorem. So we're going to say a squared plus b squared equals c squared. And our hypotenuse is c, so it doesn't really matter which side we say is a or b. So let's do 4 squared plus 5 squared equals, we'll just call it c squared. Or let's use x, right? Let's say x squared. So now we're just going to simplify. 4 squared is 16, 5 squared is 25, and now we can add those together. So 16 and 25 gives us 41, and now we can just take the square root of both sides. Now, we did introduce the square root, so we might be thinking positive and negative, but here we're trying to find a length, so we're only going to think about the positive value. So in this case, we're just going to say x is equal to the square root of 41, and 41 is not a perfect square, so in this case, this would not be an example of a Pythagorean triple, okay? But still a right triangle, because 16 squared plus 25, or 16 plus 25 is equal to the square root of 41. All right, and now for this one, we have the hypotenuse given to us, and we don't have one of its legs. So we can use our a squared plus b squared equals c squared, and let's just plug in a and b and c. So we're going to say x squared plus 15 squared is equal to 25 squared. So we have x squared plus 225 equals, and 25 squared, 625. I'll go ahead and give that a little check in the calculator, and that is correct, 625. And now we're just solving, so we can subtract 225 from both sides. Let me clean that up a little bit. Subtract 225 from both sides. And now we get x squared is equal to 400. And we can take the square root and we get x is equal to 20. Okay, so now notice here how we have all whole numbers, 15, 20, and 25. That would be considered a Pythagorean triple. Okay, so now let's talk about the converse of the Pythagorean theorem. So when we're talking about converse, basically that means they're giving us a triangle, but they're not telling us it's a right triangle. We have to prove it's a right triangle by using the Pythagorean theorem. So if we're given three sides and they say, hey, does a squared plus b squared equal c squared? Well, if it does, then it's a right triangle. Also, the converse can tell us if the triangle is obtuse or acute. And so that's what these three bullet points tell us right here. So if a squared plus b squared equals c squared, then we do have a right triangle. However, if a squared plus b squared is greater than c squared, then we have what's called an acute triangle. And if we have a squared plus b squared is less than c squared, then triangle is obtuse. So let's see some examples here below. As we mentioned earlier with Pythagorean triples, the largest number needs to be our hypotenuse of the triangle. So we can look at these three numbers and just check to see if they would even make a triangle, right? Because the sum of any two sides needs to be greater than the third side. We've done a previous video on that. I'll link in the cards right now. So if we look 11 and 14, 14 and 15, that's going to be a triangle, right? So here we're going to say 11 squared plus 14 squared equals 15 squared. 11 squared is 121, 14 squared is 196, and 15 squared is 225. So when we add 121 and 196, we get 317. And is that equal to 225? No, it is not. Okay, so we know it's not a right triangle. But we can say, okay, 317 is greater. So now that's going to give us an acute triangle. Okay, so now let's look at 3, 4, and 6. 3 plus 4, 7, greater than 6. 3 plus 6, 9, greater than 4. 4 plus 6 is 10, greater than 3. So yes, this will make a triangle. And now let's plug in 3 squared plus 4 squared equals 6 squared. So just remember our largest number goes in the place of C. So we have 9 plus 16 equals 36. And 25 equals 36. No, it does not, right? So we know it's not a right triangle. And we see 25 is less than 36. So that would give us an obtuse triangle. And lastly, 9, 12, and 15. So we're going to say 9 squared plus 12 squared equals 15 squared. 81 plus 144 equals 225. And 81 plus 144 does in fact equal 225. So since that's the case, we're going to say this is a right triangle. Okay, and so that is the Pythagorean theorem and its converse.